Hi, this is Tom, and welcome to Lesson 31, Probability from a Table. Now, I have gone ahead and I've taken the liberty to put the table in here for us already. And this is a table we saw earlier on in the semester, where we had our survey of students by gender, male, female, or other, and the mode of transportation that they used, car, a truck, SUV or a minivan, other, and then we have a total. And what we're going to do today is we are going to find probabilities from the table. So I have these written down here, and let's take a look. The first one says, find the following probabilities. 1. And you could always put the word in here in front of all these of randomly selecting a female. All right, so let's begin. Problem number 1, I think just for the sake of, we might need to reference this more quite a few times. Let's just take a quick copy of that, and let's put it over here. And not only that, but I'm going to just shrink it down, and we'll use it there. All right, so now let's tackle number 1. And we're going to write it this way. We're going to let F represent a female. And so we would say probability of selecting a female. Well, notice that if we look over here, if we look in the female row, we have 30 females out of 55 total people. So we would say the probability of selecting a female is 30 out of 55. Now, you could also go ahead and reduce that fraction if you'd like, and if you did, you could cancel a 5 out of both of those, and so you'd have a 6 out of 11. But we're going to leave ours unreduced for reasons that you're going to see here shortly. Okay, so that's number 1. Let's see, let's tackle number 2. So 2 says the probability of a female or a male. So we're going to represent males with a capital M. So we want the probability of the person being, female or male. Meaning we can satisfy our desired result with either one of these. Well, I could say that if I look at closely, we know we have 30 females and that we also have 20 males. So I could say, well, that's the 30 females plus the 20 males for a total out of 55 total people. And I could add those together. Let's come down here, and I could say that that's 50 out of 55. But let's come back and let's reflect right here for a moment. Notice that I have a common denominator of 55. I could break this into 30 over 55, plus I could break it into a 20 over 55. And when I do that, wait a minute, 30 over 55, well, we found that right up there. That's the probability of selecting a female. And the 20 out of 5, well, that came from the probability that represents the probability of being a male. And so if I finish that, what this really says is the probability of F or M is equal to just adding the probability of each. Probability of female plus the probability of male. Now, there's something that we need to recognize here, and that is this. Being female or male is called mutually exclusive. Meaning that you're either one or the other. We'll do i.e. one or the other. but not both. But not both. And so when the problem is mutually exclusive, then the problem is that simple of just adding the individual probabilities. Now, we're going to take this a little further. Problem number 3 says, up here says, selecting a person that drives a truck. Okay, let's try that. So let's come down here. Number 3 is probability of, whoops, let's do this just to be consistent. We're going to use a capital T for those people that drive a truck. So we would say the probability that someone drives a truck, well, if we look at our table here, our table is the probability that someone drives a truck, well, let's use a different color. How about the pink? The probability that someone drives a truck is right there. There's 3 people that drive a truck out of the 55 total people that we have. So we'd say the probability that someone drives a truck is 3 out of 55. Okay, so that seems straightforward too. Now, we have one more problem, and let's come down here. I'm going to write that here, and I'm also going to bring down our table. So let's bring down problem number 4 says selecting a female or the driver of a truck. So what we want now is the probability of a female or someone that drives a truck. That's what we want. Now, I'm going to come down here and let's put our table back in. We'll just shrink it down to fit. There we go. Now let's tackle this problem. So let's draw little lines here. I like the yellow highlighter, so I'll use that. So we want the probability that someone is female. Well, we have this row here of females. And so we would say, so the probability of female or truck. Now, if this works like it did with the female or male, we would say that this is the probability of a female plus the probability that someone drives a truck. All right, well, let's see what we have so far. The probability of a female, we said that that came from the 30 out of the 55. So we'd write that as 30 out of 55 plus, now let's look at the probability that someone drives a truck. Well, here's my truck, it's in the columns. So the probability that someone drives a truck, well, now we're looking at the 3, whereas here's the 30, here's the 3. So this is 3 out of 55. Now, you could add those up, but there's something else that needs to be observed, and that's this. Notice that when we counted the 3, this 3 included an overlap of the 2 females. So we counted the total number of females that drove the truck. We counted them once when we added the row, and we counted them again when we added up the column. And so what we would do is we need to subtract the probability that both traits are satisfied at the same time. The probability of being female and driving a truck. So down here in my next line, well, that comes from right there, this intersection. And that's one of the easiest ways to do this is using a table, is whenever your rows and columns for your desired probabilities intersect, then what we do is we need to subtract the intersection. And so this is what happens. Well, let's finish this. No, and this is why I left a common denominator, because now the problem is simply 30 plus 3 minus 2 out of 55. Or I could write that as 31 out of 55. And so when you had to subtract this piece here, we would say this is because the events are not mutually exclusive. Mutually exclusive. Okay? And that is how we take probabilities from a table that are either mutually exclusive or they're not mutually exclusive. But the key to all of these problems is that you're either looking for a single event, like a truck, or a female, or a single males, or you have this or piece. And notice that the or told us to add. All right, that's how we use a table for mutually exclusive events. And in the next video, we're going to look at how do we use a table for conditional events. See you then. Thanks for watching.